Howdy. Today we're going to be going over Java Basics Part 2. You'll notice my background is not my filing cabinet this time because that other video was recorded several years back and this video is recorded in 2020, so that's why I'm in my board game room. Alright, let's go ahead and get started. The first thing I want to go over are some programming terms. Compiling or building is the process of translating code written in one language into another language. The language we're going to be working in is Java. When we press compile on code we've written, it'll try to translate it into bytecode. If that process finishes, you will then have some bytecode that can be executed. If it does not finish, you'll get a list of errors on why your code is not syntactically correct. Maybe you formatted it incorrectly, maybe you misspelled an important word, and it cannot translate due to those errors. Debugging is the process of removing errors from code you've written. Now, these can be errors that occur at compile time, like you forgot a semicolon or you forgot to close a quote. It can be something that prevents translation, or it can be something that causes your program to crash when it's running, or produce the wrong output. For example, you could write a program that's supposed to multiply two numbers, but it adds them instead. That's a bug. So debugging is the process of removing bugs from your program. Executing and running. These terms are interchangeable. It means once you've translated your program to actually run it and see what it does. Programming tools. A compiler. It is software that converts code you've written in one language and translates it to a second language. If it's unsuccessful in compiling, it'll give you errors or warnings telling you what you need to fix in order for it to compile. A debugger has several tools for helping us find bugs in our program. An editor is somewhere you write code. You can write code anywhere. You can open Notepad or WordPad or Word. Anywhere you can type, that is an editor. We're going to be working with an IDE, an Integrated Development Environment. The integrated development environment we will be using is IntelliJ. An IDE comes with a compiler, a debugger, and an editor all in one software. Because it would be really annoying to write your code one place, have to take it to another program to compile it, and then if it's not working, take it to a third program to debug it. So an IDE has all those tools. Java-specific programming tools. A Java development kit. A Java development kit contains a JRE and a JVM, but you need a Java development kit to be able to build Java programs. So if you want to be able to compile your programs, you have to have a Java development kit, and that's what we're going to be installing. A Java runtime environment is something that allows you to run Java programs but not build them. So most people that use Java software will have a runtime environment installed. They're not going to be developing. If you're developing, you need a JDK. If you're running, you need a JRE. Now, the JRE contains a Java virtual machine. What a Java virtual machine is, it's a machine that will take in bytecode, the code that we produce when we compile our program, and it will translate it into instructions for that specific machine. So the Java virtual machine is the thing that actually translates bytecode into code for your machine, but it's contained in the Java runtime environment. And if you have a Java development kit, you also have a JRE and JVM because they come in the development kit. Building and writing programs in Java. Write a program in the Java language. The code is stored in a .java file. We call this a Java file. Compile the Java file. So when you compile the file, it creates a new .class file if that compilation was successful. We call it a class file, not a .class file. This file stores bytecode. Bytecode is code that can be understood by mumbling there. Bytecode is code that can be understood by a Java virtual machine. When you run a class file, the class file is given to the Java virtual machine. The Java virtual machine translates the bytecode into instructions for the local machine, and the local machine runs the program. Types of programs. We have console applications. Allow two-way communication between the computer and the user in a console. That's a little box that you can type in and get messages. Graphical applications. Programs that have a graphical user interface. Typically, these are programs with windows and buttons and drop-downs, so graphical windows. Applets. That's a little bit outdated, but applets are Java programs that can run inside of a web page. Now, we don't really write these anymore because most web browsers don't actually allow you to load applets because of security reasons. Types of errors in programming. We have syntax errors caught by the compiler before the program is executed. That should say compiler, but it says compile. Runtime errors. Errors that cause a program to crash while it's running. So you're just trucking along, you type in something, then boom, your program dies, and you get a message saying that the program closed. Logic errors. Errors that produce the incorrect output. So, like I said earlier, you write a program to multiply two numbers, and it adds them instead. That's a logic problem. It doesn't crash your program, it doesn't prevent it from compiling, but it makes your program produce the wrong result. Plagiarism. As with any class you take, do not turn in someone else's work as your own. You are not allowed to work with another student on projects unless stated in the directions. You are allowed to research problems you encounter on the internet or get assistance from me or another student. If you get assistance on a little part of a program, you need to put a comment saying, I got help from this other student on this line of code. You cannot say, I got this code from another student and paste in an entire program. You might need help on one or two little lines, but if somebody helps you with a large portion of your program, that is cheating if you just copy and paste their code. You must document in your project what you received help on and from what source. So if I help you, or another student helps you, or you're like, I couldn't figure out how to do this, so I went to the internet and I had to research this algorithm, and this algorithm came from this source. You need to be documenting where you got help on your project. In general, we would like to complete most of the project on our own, but you will run into some roadblocks where you're like, I just don't understand why I'm getting this error, or I can't get this equation to work right. So then you'll probably need some help to get through that. You should not need help to get through your entire program.